Hello guys, today I'm going to be talking about chapter 3 of the Gaddis C++ book, and where this video is going to be a bit shorter hopefully than the last one. I've got a LibreOffice presentation set up, and you already know how to run your programs and all that. You got your ID set up, text editor or whatever. So yeah, let's begin. Alright, so in chapter 2 we had cout. In chapter 3 we're going to talk about cin. This is going to be, cin is input, cout is output. So in this example I have right here, where we have the what is the length of the rectangle, that's going to be outputted, and then the cin is whether this is an integer or a double. The user will enter a number for the variable length, and when they enter it in, it's going to store that number into length. Alright, this is the full program. As you can see, the example input, the guy puts 10 for the what is the length of the rectangle and 20 for the width. These two values have been stored in their respective variables. They got put in the and then they put it into the area variable, and it gives out the result. So you don't have to you've got the freedom now, as compared to before, to let the user define the values for the integers and other data types that you'll encounter. This works with any data type. It is not limited to integers or numbers. You can use multiple variables with cin, but when you do that, you gotta make sure that you've got a space in between, because if you put how is it gonna know if you got 500,000 and you want to later enter 5 million? You can't put them side by side, or without any sort of indentation or anything. It's gonna count that as one whole number. If you don't put a space, you wanna just enter them one by one, you can do that too. If I was to enter this the integer whole, double fractional, and car letter by doing, let's say, I type in 2, press enter, type in 3.234, press enter, I type in A, press enter, it'll accept that too. Both of those methods work, but but the point is that the inputs obviously need to be separated, and it's not gonna like something like tabs or whatever. Just those two. So for section 2, we're gonna talk about the order of operations and the 4 basic 5 actually. There's gonna be the 5 basic operators that you got in elementary school math: plus, minus, multiply, divide, and modulus. The modulus operator, and it has the same order of operations as you would have in as in real life in elementary school or middle school. It's not going to be any different. And as you can see here, if you want to force a particular order, you can use parentheses. Don't use X to show multiplication. Use the asterisk And for divide, you got slash. Don't use backslash. Modulus, use the percent sign. If you want to get exponents to work, you gotta include the CMath library. There's multiple ways of doing exponents anyways. Such as making your own, multiplying a number, an arbitrary amount of times. Like, let's say you want to get pi squared, you could just do pi times pi. That could work. And later on, when we get stuff like functions, we will know how to make our own functions, or we will know how to do with loops. There's other ways you don't have to use CMath. You can make your own solutions. But anyways, area equals pi times pow for power. You put the thing you want to raise the power and what that power you want it to be. So this is a area of a circle, radius squared, so radius comma 2.0, and you'll get your result. Yeah. Alright. So, as you know, there's a bunch of multiple types of data types, and you've got doubles, integers, and floats, characters. But the ones that you want to think about when you talk about ranking are ones listed here. There's that one data type we talked about earlier, strings. Those weren't mentioned in the book. I think they'll get treated as a 32-bit data type. It'll be like equal to double or something like that, like in terms of ranking. Maybe higher, depends on the system, I think. Like, depends on what compiler you're using. But you wouldn't really be using strings and doubles in the mathematical, like you wouldn't be adding those two together anyways, so this isn't something you'd be worrying about much. This mostly has to do with when we're trying to add two of these together or subtract two of these together or doing some other operation. Okay, there are 3 rules for these data types. The first rule, as you can see, characters, shorts, and unsigned shorts will be promoted to integers regardless of what you're doing, whenever some mathematical expression is involved. The lowest data type will be promoted to the highest data type when you are using 2 different data types together for the second rule. And that means that if we have, in this case, years, which is an integer, and interest rate, which is a float, before we multiply, years will be converted to decimal number. Even if it doesn't have any actual, any information in the decimal places, like you got 3.0000 years, it's like it's just 3 years, but you convert it to, it's going to be converted to float. It's going to include decimal points before you even have it get multiplied. This means that you always have promotions in this case. But when you're storing variables, if we have something such as the area, like a variable called area, and it's declared as an integer, then even if you had this years times interest rate, which both of them got turned into floats, those 2 floats where that result will be converted, it will be demoted into an integer, or in this case a long integer. Something I like to point out, this isn't one of the rules that the book mentioned when I decided to add it as a rule, because he kind of puts it right after, and it's like something that I encountered when I was typing out all the solutions for the problems, was that when you have two numbers you're trying to divide and you want it to have a decimal result, like you even declared it as a double, you want a decimal result, but you put in like 15 divided by 6. If you don't give these a 0.0, or at least one of these a 0.0, then your result will be an integer. So when it stores this, it'll be not even a round up. It just gets rid of whatever that decimal number was. So I think this was like not a think. This was 2.5, and that's the actual result. You should have a 2.5 when you divide 15 and 6. If you don't believe me, divide the top by 3, you get a 5. Divide the bottom by 3, you get a 2, so that's 5 over 2, 2.5, basic math. You don't get a 2.5, you just get a 2. It doesn't even round it up. Over here, however, if you want to do that, so you want to put it as 15.0. So be careful. This will kill your program. Imagine if you're working on something really important, and you wouldn't like the professor, especially if it's like you're in university or something, you're trying to make your own program to make a lab easier or a lab report easier, and your professor's saying, "Oh, I want my significant figures," and you don't give him significant figures, you give him a bunch of integers, and the guy's wondering where all of your decimal points went. Be careful. Alright. For section 4, we got this thing called Overflow and Underflow. But this is more of a review of chapter 2 stuff. When we were talking about the sizes, I thought if they low key kind of meant what were implying this by default when they said something was only 2 bytes or 4 bytes, but they wanted to make it clear here that there's a reason why it matters how what size a short is, what size an integer is. A short can only store up to 32,767. If you go higher than that, you get an overflow, and this turns into a negative number. And if you were to add subtract a 1 from that, it goes back into that highest possible positive value. So remember when we were talking about how there's rules for promotion and demotion? Well, you can choose what you want the data type to be in case you want to micromanage. You want to make sure something is a double or make sure something is a positive. But go read the examples for this, because just looking at some explanations wouldn't help. I really recommend that you actually look at the example programs in full and keep inputting a bunch of values to see what happens. Like this is like a piece of the program. He wants to force it into doing a decimal value. Alright, so when you want to say a variable equals something, you got cin, you've got just calling it a number, but there's all other tricks, like saying number equals number plus 1, or number equals number minus 5, or more complicated solutions such as doing whatever this is. Multiplying itself by the sum of a plus 5, which a is going to be defined elsewhere. This is probably an integer in this case. And, you know, that's a neat feature, but maybe don't do that too often unless you're absolutely sure you know what you're doing. There were some crazier examples this book did that I don't think would be ideal. Alright, so the programming challenges in this book asks you a lot for good reason, has to do with what's the stuff in the 7th section is having the correct amount of decimals. If you print something with that's stored as a double, you're going to get whatever amount of decimals that number has, or at least like the first 10 or something like that. And if you're working with money, we don't have more than 2 decimals. You just have 2 decimals. You don't have something as a thousandth of a cent, unless you're thinking about maybe converting currencies, like, you know, Iranian rial to a dollar. But that's not legal tender. No one deals a thousandth of a cent. So your program, you want it to show if you want to just show a limited amount of decimals or a lot of decimals, like 50, then you have to tell it. This section will tell you how to deal with that. So this is not that. This is some other formatting. I'm not even going to talk about this. It's important, like when you want to format some of your programs, but don't think about it too much. So this is something I want to talk about that the book doesn't really show all too well. I want you guys to look at this program and think what the results are going to be. I want you to see the importance of set precision and fixed. I'm going to pause the video, think about what the output is without, trying it out yourself, and then come back after you're doing that. There's something I want to talk about. Okay, let's go. So these are the results. So as you can see here, we have 10 digits, even though we wanted 10 decimal places to show up. We have no decimal places shown after 0, after this 5. We have all digits shown, both decimal and the first 3. And we have all decimals plus the zeros, plus these extra zeros. And what happened here? Well, set precision by itself is useful, but I don't think it's as useful as it could be. This 10 only gives us it gives us 10 digits, alright, but not 10 decimal places. So when you want to show complete values, as you can see here, we only had we didn't get the 374, but someone who's using set precision 10 would probably think, when 10 means 10 decimal places, right? Nah, it includes all digits, so you have to account for that. If someone consistently wanted 10 decimal places, regardless of the size and magnitude of the number, or if there's anything beyond the second or third decimal place to begin with, they have to use fixed. And as with anything, you can put any variable in here. So like if you had 99, it probably would work, but you don't want to really test that, because unless you have a big enough of a big enough of a data type that can handle it, that can handle that many decimal places. Okay, so section 8, there's this library that lets you have strings of text, and when you enter those in, you cannot just use cin, like this, the cin with the two arrows, and the greater than signs in this context. You have to use getLine, because if I did, let's say, ask me my first and last name, like over here it says, please enter your name, and it does Kate Smith, it wouldn't actually give us Kate Smith. It would just give us Kate, and for that second prompt it says enter the city you live in, when it's got the CN, it would put Smith for that city, and it would do, hello Kate, you live in Smith. And you can see that in a textbook, it talks about that. So you always want to use getLine when you're dealing with strings, like always, because it's just better, it's more convenient, less worry to deal with. I talk about what I just said right here. There's other ways of getting input from the user. So if you want to get a character from someone, you could do cin.get parentheses ch for character, or have the character equals cin.get. These all do the same thing. And regarding strings and operators, you can add strings together, while you can't subtract strings. If you want to know how long a string was, like how many letters it has, there's this function, for instance, that gets the length of the string. You put the variable name, so in this case it's state.length. It'll give you the length of the string. And for section 9, there's a bunch of mathematical functions in CMath besides the power function, and you got cosine, sine, tangent. It can be very useful for your mathematical projects if you have any, or to make your assignments easier if you don't like using a dedicated calculator as much. But it's somewhere to start. There weren't many assignments that dealt with this, but it's useful. Here we see CMath using the power function as we saw before. Oh yeah, this is really important. So if you're trying to make a game, chances are you want to be making you want to be using some sort of random number generator for something. A lot of games do that, and I don't know, since we're not going to be using any graphical interface, that means it's not going to be something advanced like a first-person shooter. In this textbook, we're not going to use any graphics because this book doesn't talk about graphics. You might be doing something like a dungeon simulator or whatever, and it's a bunch of text prompts, and you gotta have some way of changing things up, right? So you probably would be using a random number generator. And besides stuff like games, you want to have maybe some sort of simulator, or you want to have maybe something for statistics. I don't know. There's a billion possibilities. But one thing that random number generators need is a seed. And if you don't seed your random number generator, you're going to have problems, and that problem is that you're going to get the same results every single time you run the program. Now it might be different from computer to computer, but it's not going to be different from when you're running the program on your own computer more than once. It's not really random. Time is a very seeding your random number generator with time is a very basic solution. It gets the system time, and it will change things up a little so that your random numbers are different. And if you run your program, it still has this big problem where if you're trying to run the random number generator, like you're trying to run it more than once within the same second. Let's say you start the program, run the random number generator, then end the program and restart the program in the same second, then you're gonna get the same results. But it's not that bad. It's a big step up from getting the same thing every single time. So something to consider. You want to seed your random number generator. Section 10 and 11. This is more so of philosophical stuff, like how you want to go through your program if you're getting something wrong, you can't understand it or whatever, or it wasn't exactly what is hand tracing a program. Come on, it wasn't exactly something that could be dealt with a slideshow. And max value, min value, that's part of section 9 for your random number generator. When you want to tell you, like, you want to make dice, for instance, you put the min, you put the max, you use a modulus operator. But yeah, thank you for watching chapter 3. For all you students out there, or people who like watching stuff, just for fun, whatever made you stumble across this video, thank you for watching. Leave a like or dislike, or don't do anything at all, and see you later.